All set? Awesome. So we're just about an hour mark, so I'm going to start right now, because I still have a plane to catch right after this session. Just out of curiosity, how many of you attended my session yesterday on Azure SQL databases? Raise of hands. Good. Thanks for joining me again. That's probably a sign that you enjoyed my presentation yesterday. Today's presentation is not going to have anything to do with Azure SQL databases. It's more about containers and Docker support in Windows, in the newer versions of the Windows operating system, both client and server, and in Azure. Before we delve into, let's give a round of applause for our sponsors and especially the organizers for putting up such a great event. Come on, guys. Woo! That's good. Thank you so much. For those of you who don't know me yet, my name is Alex. I come from Romania, more specifically from Transylvania. I'm one of the Azure MVPs, and I will have the pleasure of talking to you right now about Docker. Another raise of hands, how many of you are actively using Docker right now? Good. That's usually the sign. How many of you have heard about Docker? Yeah. You guys are at the right session. So basically, the purpose of this session is to actually explain what Docker is and how it will change the world eventually, at least in my opinion. Ever heard of this company? No. This is the company which brought us the best operating system in the world, which has revolutionized internet browsing. Everybody knows them for that. And whose CEO would say something like this. Now, this was only 10 years ago. After 10 years, things have changed. On one hand, they changed their logo. On the other hand, they also got their feedback right. And they brought up a new operating system, a new browser, which actually runs pretty good. They've changed the entire operating system so that it runs on so many different platforms. And most importantly, their new CEO went from Linux is a cancer to Microsoft Heart Linux. How cool is that? Now, that's quite a shift for a big corporation like Microsoft, in my opinion. And especially if you think about all the devices they're doing right now and nowadays. I'm just jealous of not having one of those on my desk right now. They also do all this kind of innovative and holographic devices, which are cool. Super nice. So what does this have to do with the entire conversation about Docker? Well, turns out that another thing they've changed and which has shifted for the past few years is that they also went to the open sourceness world, right? 10 years ago, you wouldn't say, hey, Microsoft, open source. No, we don't like that. That has changed completely, but absolutely completely from its roots. Right? They're developing and they're creating an operating system, Windows 10, to run on Raspberry Pis on devices which only cost like what, $40 here in Poland? They're actively contributing and open sourcing their entire libraries on GitHub. Did you know that 2 weeks ago they were named the #1 contributor on GitHub, even larger than Facebook? It's just crazy. Yeah, that's Microsoft nowadays. .NET has been open sourced. Their compiler is open sourced. All their libraries and the entire system frameworks they have are open sourced. If they have a problem, like some people know that it's not always good to use lazy as an object because that might have some problem at very large scale systems, we can take this conversation offline and talk about it later. If you just go online and look at the code within lazy, you might even realize what the problem is. And it will take a few months until the update is over there and patched. But the thing is that you can right now figure out where the problem comes from. This is Microsoft nowadays. So when we talk about the cloud, just scratch everything I just said so far. When we think about the cloud, there are like 3 large pillars we usually focus on. First, there's availability. Now, in today's world, if you're watching a movie, do you have Netflix here in Poland? If you're watching Netflix and for whatever reason Netflix doesn't respond or you can't watch your movie, you're like, what just happened? I want to watch a movie. I don't care about what they have underneath and how much scalability and disaster recovery and how high availability they have. I want to watch the movie right now. 2 or 3 years ago, it was completely different than that. It was like, yeah, the website doesn't work. That's OK. I will try again in 10 minutes, maybe in an hour, maybe tomorrow morning. I don't care. that has changed completely, like completely. Of agility, which basically means, you know what, I need another cluster of VMs which have 400 whatever gigabytes of RAM and 64 cores. Sure, there you go. That's Azure for you. Hyperscalability. It's just mind-blowing, if you ask me. Just mind-blowing. This has changed completely the way we think about scalability, the way we think about our applications, the way we think about providing services to our customers. So what is Docker, anyway? When we usually say Docker, we also automatically think about containers. But don't be tricked into believing that Docker invented containers, because containers have been around for the past at least 10 years or so. Docker is just, it used to be a startup. It no longer is a startup. It was the fastest growing startup in America, like 2 years ago, which ended up having a revenue of billions of dollars, right? A startup. It's just a startup. It's just a company which revolutionized the way we think and use and manage containers. So when we think about containers, and I really like the picture over here because it sort of explains the way the system works, there is the concept of an image. The image is taken from Docker and run within a container, and I will delve into the concept of a container immediately, and then runs with a shared kernel. So all the code, all the runtime, all the system tools, all the system libraries, they represent a single package. And the idea is, within your application lifecycle, when you want to build and run and deploy after you run your tests, you have a single package which moves from one place to the other. And the cool thing about it is that because you will know what the workload and what a host is, either Linux or Windows, you can run that particular one thing on AWS, on Azure, on whatever you want, on your own data center within your company. And why this is important is the fact that there's, in my opinion, no lock-in like the cloud lock-in. So just think about whatever cloud application you have developed. The moment you know that you will develop a cloud application, you will start implementing best practices for sure, such as throttling, handling, whatever other kinds of latency problems you might come into have to be handled, right? Sessions, stateless applications will also be implemented based on the best practices you have, and so on and so forth. And that's sort of general, and that's available and should be implemented for both AWS, for Azure, for Google Cloud Engine, for whatever. But when you have chosen your platform, may that be Azure, may that be AWS, you name it, you're sort of fixed and constrained to the libraries, commandlets, to the REST APIs they have. So nowadays, in my opinion, developing software is almost like building blocks, like Legos. You take this library from here, you take that NuGet package from there, you take whatever other third-party, that DLL, and you end up creating an application which runs on someone else's computer. And that's the definition of the cloud, someone else's computer. Now, here's the thing. I just said there's no lock-in like the cloud lock-in. The reason for why I said that is that the moment you have chosen that your application will run on Azure, if your CEO comes in and says, you know what, turns out that AWS could be cheaper because somebody from marketing from AWS said it's cheaper. Let's do that. It's not like you snip your fingers and 1 hour later you're running on AWS. No. It takes time to implement the new libraries. It takes time to delete the old ones. It takes time to test your application. Because even though your application is the same and the business logic is the same, it runs differently, right? It has to handle different libraries. And here's where Docker comes in. The idea of a Docker container is that you no longer care about what are the libraries which I'm running on. You just have the shared things, and they go on a shared kernel, and they just run in an isolated model. Now, why Docker? First, from the lightweight perspective, it's a shared kernel, and it's a layered system. Second, from the openness, the thing is that it runs both on Linux and Windows, and I honestly love that. And I will delve into more into the conversation about Windows in a second. And then it's secure. And when I say it's secure, it's basically everything which runs within the container is isolated both from the other container and from the host where the containers are running. So just think of a situation where you want to install, like, your application has a data layer, like the persistency layer, your SQL Server machines, has a business logic layer, your REST APIs, whatever those are, and has another presentation layer. If you want to install all the layers on one or more VMs or whatever, doesn't really matter. You'll have to install SQL Server. You'll have to install IIS. You'll have to install a bunch of different server roles for Windows, right? And eventually, your application will run. But if you want to move one of the layers, like the persistency layer, from this VM to the other, as a best practice, you should also delete all the dependencies and SQL Server as an instance itself from the VM. And that takes time. Why? Because everything is installed within the machine. In terms of Docker, everything is not installed on the host. It runs within the container. And if you just want to update your application to a newer version, you kill this container and bring up something new with a different package with the updated binaries you have, which also contain the binaries which are dependent on SQL Server, for example. I will show you how that works in a second. Now, why do developers usually like it? First and foremost, because they can build, theoretically, any language using any tool chain. And when I say any language, it's almost like saying any application runs on Docker. And that's what marketing people usually say. That's not exactly true. So if you're one of those people who develop remote apps, VDI infrastructure and stuff like that, those will not run on Docker because of the shared definition of what a VDI is, right? Then Dockerized apps are portable. That's like the second most important reason for why developers like Docker, like me. When I say it's portable, I actually mean that I can develop and run my application on my computer, on my development machine. And once I know that my application runs as expected, I will take it over to the QA team. They will rest assured that from their perspective, the SLAs are acceptable and so on and so forth, and the application runs OK. And when the application runs in production, it's the same exact package and binaries and libraries and everything like that that should run. And that's Docker for you. Like, there should no longer be a situation where your developers will say, well, it runs on my computer, right? How many of you have heard that? Like, every single hour, you probably hear that. It runs on my computer. You must have done something to it. There's also a NuGet kind of things, or a GitHub, if you want, for Docker, which right on my slide says has over 13,000 different apps built upon Docker. Actually, the number is pretty larger right now because so many more people are embracing the idea of Docker and Dockerizing their application, which is another interesting word. And it helps you build and ship your high-quality apps. And it will be fairly obvious once I will do my demos in a second. Now, why do sysadmins like it? Because the same situation again when if a developer asks sysadmin during his watch time of Game of Thrones, because that's what they usually do at the workplace, right? If a developer asks for something like, hey, you know what, I need a new container which will run this application, which has just been updated to run over the newer version of IIS, they'll just write a single Docker file, and that's your container for you. They'll give you the container. You, as a developer, can spin it up, can run it, and there you go. If you need to change something, you will layer the entire infrastructure of your container from the Docker file and write something upon it, and your sysadmins will know, hey, there's something newer which has been changed by the developer because it did something. I will show you how that works. Now, as a comparison, because if you just think about what I just saw so far, it's very similar to what people used to say back in 2005 and 2006 when virtualized environments became more and more popular. Isolated things. What was like the main #1 reason for why virtualization was so popular in the first place? Anyone? Come on. Capacity, right? Everybody was saying the same thing, which was, hey, you know what? We need an Exchange server. So we need this particular physical hardware, which will probably run at 20% of resource consumption. We'll need the other edge role. We need the whatever front-end server. And those would be different machines running and doing different things and so on and so forth. But they would only run at probably maximum 30% of their capacity because you need to have more resources available to you should the consumption grow. Now, the problem with that thinking is that you end up paying more money for your IT. You end up paying huge amounts of money for your energy consumption, for your power consumption, and so on and so forth. And the #1 reason for embracing the entire idea of a virtualized environment was, #1, you don't have to install everything on a single OS on the physical hardware. You can virtualize your OSs and isolate one server role to the other so your maintenance windows are as small as possible, but still have a resource utilization of up to 80% or something like that, which would ensure you that you no longer pay for running idle VMs. So the difference from a VM to a container, though, is this thing over here, right? The hypervisor and the guest OS. There is no reason for you, and for the purpose of the recording, let me do this with my pointer as well. You no longer have a hypervisor. Instead, there's a Docker engine. I'm not a huge fan of this diagram over here, because the Docker engine itself is actually not an actual layer which sits underneath your application, but something which should probably be somewhere at the side of the diagram. Because it's more like a thing, a doorman, which only says, hey, you know what, this is a new container, you go over here, you go over there, and that's basically it. It's not a host by itself. On the left side of the diagram, though, the hypervisor was underneath all the VMs. And if you just look at it, you immediately realize that you needed resources such as memory, such as CPU, such as storage space, and so on and so forth, to actually run the guest operating system as well. Right? So for each new web server you wanted within the different VM, you had like plus 10 or 5 at least gigabytes for Windows, plus 2 gigs of RAM at least. Right? And all those consumptions means money eventually, only because of isolation. So the idea of a Docker container is that you strip down the guest OS parts of the diagram, you strip down the hypervisor, and you only run your applications dependent on the binaries and on the libraries on the shared kernel of the operating system. And that's basically it. Now, if you want to do an analogy, just think of it like a house. If you want to build your house, it's like building your own infrastructure with your VMs or only with your physical servers. You'll need plumbing, you'll need electrical installations, you'll need a roof, you'll need a lot of different things. If you want to build your smallest house, it still will probably have a garage, it will still probably have at least a kitchen, it will still probably have at least a room where you'll put all your dishwashers and your laundry washers and so on and so forth in it. So you end up paying so much more because you need to have things which actually make the house run. If you want to think about containers, they also actually look something like this, like a big building of apartments, where you have the same plumbing for all the containers, where you have the same electrical installations, where you have the same roof for everybody. And the security in the house is like your door, right? You still have your doors and your isolation from one apartment to the other in the condo as well. But over here, you'll also have a doorman, probably or presumably, you'll also have a doorman. Now, that's not more like a security officer. It's a doorman who only knows Alex Mang lives on apartment number whatever, so if you want to do anything with him and talk to him, you should go over there. Right? This is what the doorman does, and this is what your Docker engine will do. It will only tell you, you want to hit port 80 on that particular container? Well, actually, here on the host, that's port number 30,000 whatever, so just hit this port, and that will redirect all the traffic to that container on port 80. And that's what Docker is. Now, don't think of it that it's different but mutually exclusive. Because what you can also do is that you could have your operating system running Docker engine and having all the containers within the operating system directly. But if you want, you could also go in a situation where you have a hypervisor upon your physical servers. So that means VHDs, VMDKs if you're a VMware guy, whatever. And upon your hypervisor, you can choose to have your operating system, because that's a requirement, which can either be Windows Server or Linux or you name it, and have your containers running within the VMs upon that hypervisor of the physical server. Does this make any sense? Good. Now, the reason for why you want to do this is actually one of the requirements of Docker. So when you run a container, you will know beforehand what the workload is going to be. Is it a Linux environment or is it a Windows environment? You cannot migrate right now from one to the other just like that. Eventually, presumably, you will be able to migrate some of the containers from Linux to Windows. But that's still a long way to go. Docker for Windows is still on the beta, the one version which contains this particular feature. That's, I don't know, version 26 or something like that. So, Docker plus Windows Server equals Windows containers. What does this mean? So Microsoft just announced 2 weeks ago, back in Atlanta during Ignite, the full support for containers on Windows Server 2016. And here's what they did. So originally, Docker was designed and developed to work on Linux environments because of the user namespaces models, because of the process isolation models, and so on and so forth, which basically made it like a no-brainer to implement containers on Linux. Don't hate them for that. It was way easier to do it. 2 years ago, Microsoft ended up realizing that, you know what, the container strategy and the container terminology and theory and so on and so forth really makes sense. So we should do it, said Microsoft, by ourselves as well. Turns out they called Docker, and somebody from Docker came in 2 years ago, and Microsoft asked them, well, we want to have container support in Windows. What should we do? Well, you can just implement Docker, they said. Well, yeah, but licensing, IP, stuff like that. Turns out they didn't know beforehand that Docker was open source from like forever, right? So what they did, they implemented Docker, and they worked alongside with the Docker teams from Canada to have container support within Windows. And this is a 2-year collaboration between the two companies. And when I say collaboration, it's not like we'll email you each month on our progress and you just say yes or no or something like that, or out of office. No, it was an actual collaboration where people from Docker would come in the office at Microsoft every single day, or people from Microsoft would go at Docker, and they basically developed their own products together. Right? So when I say there is full container support, natively supported on Windows for Docker, I actually mean that, and the team actually did that. Okay? So the way this works is that upon Windows Server 2016, and just that you know, Windows 10 also has full container support as long as you install Anniversary Update. So you might not have known this, but if you just go to Control Panel and choose Programs and Features and choose Turn Features on or off, there will be container support over here. Geez, I didn't activate Zoom it. Just a second. Demo gods, are you on my side? Yeah, there we go. Containers, right? This only pops up after you install Anniversary Update. And it's the same kind of thing. Good. Now, there is also the concept of a Hyper-V container, which is basically a lightweight version of the hypervisor you know and love, Hyper-V, right? But the idea is of having all your containers in an isolation model of a virtualized environment, right? So when you create a new container, you'll also specify what the isolation model is, and the default is something like this, where all the isolation models run on the same shared kernel. But on the Hyper-V isolation model, you will have your own Windows Server operating system kernel running for that particular VM. Now, the reason, container, sorry. The reason for why you would want to do this is especially for compliance reasons. So if you have like a PCI compliance requirement, they will tell you, you know what, we cannot accept multiple containers or roles running on the same shared kernel because that's a security vulnerability. All you have to do is specify an extra parameter and have the hypervisor activated on your Windows operating system. And just say, isolation model, Hyper-V, boom, there we go. And the virtualized environment will take care of that. Now, I know I've talked a lot about an entire thing about how containers change the idea of a virtualized environment, that you no longer need a guest OS. You basically end up paying less licenses and so on and so forth. But don't take me wrong. Hyper-V is not going away, right? Containers, and the purpose of containers and Docker is not to move you away from a Hyper-V environment. Because things like clustering, things like disaster recovery, things like high availability and scalability, Hyper-V will always be better, at least in my opinion, than a containerized environment for that. Still, containers is like the next big thing, especially for microservices, and especially if you are OK with using the same shared kernel. That's not to say that there isn't a clustering support for Docker. That's Swarm, but I'm not going to go into that. There is something like that. So Swarm is a clustering system and engine for clustering containers in Docker. But their clustering technology is not as mature as Hyper-V's, obviously. And it's not meant to be like that either. Now, if I want to do another comparison between containers and VMs, one thing I really like and really love is this diagram, where the operating system basically runs your application and your kernel, and upon the kernel can also run alongside with the applications all the containers themselves. In a traditional VM environment, what you normally have is the hardware with the operating system and all the single VMs running alongside the operating system which is installed on the physical hardware. And here's where the cost implications and the agility thing comes in. If you want to spin up a new VM, it will take you time, and it will take the automated process time to spin up, to install the VM, to allocate resources, and so on and so forth. Unlike here, where it's only a matter of, hey, here are the binaries, here are the libraries, running in a single process in an isolated model. There you go, boom, and it runs. So rather than having tens of minutes or even hours for a VM to run up and spin up and be fully provisioned, it will only take you a few seconds to have the container running. Now, there's also this concept of a Docker file. Let me just look at how we stand on time. OK, there's also the concept of a Docker file. And the idea of a Docker file is to allow sysadmins, or even developers for that matter, to specify how your container should look like. And there will always be a from, and this is the Linux example. There will always be a from which tells what is like the scratch thing, the root thing, from which my container will start. And afterwards, it will only have like a bunch of different commands, and each and every single thing from here will represent a part of the layering system of Docker. So I could have container Alpine latest, and latest is a tag which says that this is the latest version of the container named Alpine, right? From that, I want to do this other different bunch of things, and this is my Alpine enhanced version. Somebody can afterwards take Alpine enhanced, run some other commands, and have Alpine enhanced version 2, or Alpine even more enhanced, right? And that's the idea of contributing and having repositories and creating Docker files in order to create containers which are progressively becoming better and better. Now, how many of you know Python over here? I shouldn't raise my hand because I'm not a Python developer. What does this thing over here tell you if you're a Python developer and look at it? Like, for example, the last command. Yeah, it's just running a command Python, which will specify as a parameter for Python, this is the particular application with the Py extension that I want to run, right? So if you're a Python developer, you'll know that in order to run something, you'll need some dependencies, and I will install some things over here. I'll specify some requirements. I will copy over some files to a particular folder. I will expose 5000. What does this mean? I will expose port 5000 for TCP connections, and I will just run this particular command. So basically, when somebody runs the container defined on this file, what actually happens is that they will end up having a process which does all these things and eventually runs the application using the command Python and the argument of the application file. Does this make any sense? So from a Windows perspective, how this changes, and I'm actually showing this as a snippet, as a screenshot from GitHub, because everything is open sourced, everything is available on GitHub. You can look at it right now. So what I'm doing here, what they are doing here is that they're specifying that they want to start from Microsoft .NET version 1.0.0 preview to Windows Server Core -SDK. This is such a Microsoft name. Come on. And they will just PowerShell, and they will specify a command, and they will just run a bunch of different commands, and eventually they will have command.net run -p parameter specifies the location, music store standalone. And it's the same thing. You end up having a container which depends on .NET 1.0.0 preview to blah, 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 which after the configuration steps will run your application. And that's your container with your application for it. Super simple-ish. From the architectural perspective, and this is just something I'm trying to do here to explain you all the different words. When people say Docker, they actually mean a particular one thing. But there are so many different Docker keywords and Docker words that it's not always clear, right? So there's a client. There are a bunch of different clients, actually. One of them is Docker, and you can use the Docker client, which basically means the Docker like CLI thing, to run different commands. One command is build, the other command might be pull, the other command might be run, and so on and so forth. I will explain those in a demo right away. Then there's the Docker host thing. This is basically the operating system which has Docker support for within the operating system, which can be a Linux environment, a Windows environment, you name it. There'll always be a Docker daemon, and the Docker daemon is actually what makes everything happen. So when you run docker build, Docker daemon will take the command and it will build an image based on whatever your Docker file, like this thing over here, is. And it might take that image from the images saved inside of the Docker host. So on my machine, I can save images which are built from the Docker file from blah, 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 do this, command, do that. Or I can also take images from the registry hub. The registry hub is the NuGet kind of thing Docker supports by themselves. Some people sometimes ask me, how does Docker end up being one of the most highly successful and best paid and have such big revenues as a startup if everything is open sourced? Well, they also run something called Docker Cloud. And the Docker registry, just like GitHub, for example, has public repos and private repos. Now, those private repos are paid for, being paid for. You can also have your private repos not running on their infrastructure in the cloud, but on your own on-premises data center. That is also a license you have to pay for. And only for those two small things, they end up being the most successful startup in history, I think. Which is still mind-blowing. Not the fact that I think, but good. And then there's containers. So on the Docker host, you'll have the Docker daemon, which is the thing which makes everything work together. The images, which might also come from the registry. And if your image does not exist locally, it will be downloaded from the registry hub if that exists. If it doesn't exist, you will just get an error back, obviously. And afterwards, that image will end up being a process, a container, with the binaries, the libraries, and the application, and everything running within it. Now, this is an older architectural perspective. And I say it's older because in Linux, it's still the same thing. So the host runs both the client, both the daemon, and the containers. Back on Windows, like a month ago, it was something like this, where your Windows operating system would run the daemon, right? The one you'd normally talk to when you write the CLI commands, docker build, docker run, docker push, docker pull, blah, blah, blah. And that particular daemon would talk to a different host, which was running inside a VM on a Linux distribution operating system. Because as I mentioned, everything was Linux-based. Now, this has changed with Windows Server 2016 and Windows 10 in a way that what you have here in the gray area disappears and looks more like in the Linux world, okay? Why do you have to choose one workload, either Linux or Windows? Well, because the process isolation model is different from the one operating system to the other. And the kernel is obviously completely different. So they have to write the particular container for the particular operating system they want to do. Good. There are a bunch of different Docker clients. Docker is the main one. There's a Docker machine, which will no longer probably eventually exist, or I don't mean exist, but I mean something like if you'll only run on Windows, you'll probably not need it anymore, and that will make a lot of sense in a second. Then the reason for why I want to do this is Docker as a CLI is the one thing which starts containers, stops containers, kills containers, removes the images. I will show you those. Docker machine is the thing which creates the Docker daemon to run the host so that you can support containers on that machine. Good. time for a demo, eventually. After all the mumbo jumbo about Docker, it's time for the demo, right? So the first thing I'm going to do is that I will use PowerShell. And honestly, my PowerShell skills are close to none because I'm a developer, and I was always reluctant on, hey, I have to learn a new scripting language for real? But yeah, you eventually end up learning PowerShell. It's not that difficult, especially in the context of Docker. So what I'm going to do here is that I actually have a cheat sheet nearby. A cheat sheet is something like a prepared demo because of the internet connection experiences I had yesterday. This was like, ugh. So in PowerShell, if you have a hash sign, this is basically a command. And what I'm doing here is that I'm trying to show you how I would create a new machine to run on Hyper-V, right? And the command is docker machine, because this is the CLI that I'm going to use. Is the image OK? Can you all see? Ish, right? Sorry for that. Let me just delete the hash sign so it probably becomes more visible. So if I would hit enter, what would happen is that the CLI, the Docker machine CLI, would create a new environment for Docker containers running on Hyper-V. Now, the way this works is that what's actually going to happen is that it will create a new VM on my hypervisor, on my laptop right now. It will download everything like the small, lightweight Linux distribution, which nowadays is called MobiOS or something like that, hence also the whale from the logo of Docker. And I specify that I want to run on Hyper-V because of this particular parameter, which is -- driver. There are also other drivers, such as VirtualBox, and this was the main one and the first one which ended up existing. So all your hosts would originally run on virtual PC. And at some point in time, they also brought up Hyper-V as well. And the one I really love, because I'm an Azure MVP, is the Azure one. Now, the Azure one is by far, in my opinion, the best, because it runs on Azure. So I also hit enter because I added this particular parameter called help, and almost all the commands you have. What did I want to do here? No, not that one, not that one. Oh, OK. So basically, help, this particular parameter over here, will list out all the different things I can do. And each and every single driver has its own list of parameters. So in terms of Azure, I could basically specify, hey, what's the particular Docker port you're going to use? Is it something else than the default? What's the name of the environment you want to create? What's the resource group name you want to create? Do you want to open a particular port, like port 80? What's the size of the VM which is going to run your host? Will be on Azure. And the cool thing about it is that when you're done testing out Docker, you just delete the resource group and poof, everything is gone. You don't have to install any new binaries. You don't have to install a hypervisor. You can run within a VM, if you know how to do that, like Inception, right? You can do those things as well. And those parameters are already existing. Now, the moment you'll do it, what's going to happen, and I basically ran this particular command over here, which basically says Docker machine, create a new machine on the Azure driver. This is the idea of the subscription I want you to use. Open port 80 and give a particular name to the machine. What's going to happen right then is that it will create a complete resource group with virtual VMs, with NICs, with network security groups, with storage accounts, with blah, 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 whatever is required for a VM to actually run on Azure. And not only that, but it will also provision a particular image based on an image template defined within the Azure gallery that would run this particular machine. So the resource group is this one. By default, it's called Docker machine. And it contains, in a second, OK, it contains a bunch of different resources. I'm not going to waste any more time on that. Good. So what I'm going to do next is that if you just want to check that you have Docker machine installed, you can also do .version. And this parameter over here would list out the version I'm using right now of Docker, which ends up being a CLI, so basically a different process. And I want to point out the version, and that's 0 point something, because Docker machine is still in beta, unlike the full Docker CLI, which isn't. Another thing, a neat thing I want to do is use the ls. The ls parameter will list out all the machines I have created and registered on this particular environment right now. And as you can see, I will have my Azure machine listed out if my network support is good enough with me. Fingers crossed. Yeah, timeout. Let's try that again. Normally, this would not happen, obviously. So there we have it, our Docker machine running on Azure called DeveloperDays machine, which isn't the active one because otherwise I would have an asterisk, which would tell me that this is the default machine all your Docker commands are running onto, has a particular URL, has a particular version running and stuff like that, and is running right now. So I could run containers on that. Now, I could also do things like Docker machine IP and specify the name of the machine like DeveloperDays machine. And this will tell me what the IP address, what the public IP address from within the Azure data center is in order to run that particular Docker machine. And there you have it. So everything I would run as a container and should be publicly available through the particular port would go to 13.93. blah, blah, blah column and the public port I'm listening to from the host of the Docker containers. Now, enough about Docker machine. This is going to move away, and you'll see that why in a second. Docker is the other CLI I'm going to use extensively throughout this demo. Now, the Docker CLI is the one which runs containers, lists containers, kills containers, and so on and so forth. So if I just do Docker PS, I will see within a table that I don't have any containers running right now. This is only the header of the table. So what I could do is specify Docker hello run hello world. And this command right here would say, I want to run a new container. And the container I want to run has the unique identifier of hello-world. Now, there are two situations. I either have the Docker image, which configures what a container is going to do and how it's going to be initialized, installed locally, or if it's not installed locally, it can be in the registry hub. And let me just, before hitting OK, let me just do Docker images. This will basically tell me on my active Docker machine what are all the images that I have right now, okay? And those are Ubuntu, Nginx, WordPress, and Hello World as well. And that ends up having the latest tag, which basically means that this is the latest version I have of that particular image running. So if I just do the Docker run hello-world, it will run and create a new container based on that image. So I'll just click Enter, and there we go. Here's the result of what a container did. And what a container did, just remember the Docker file from blah, 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 command do something was to output, using the echo command, this particular message and whatever comes after that. So if I do Docker PS again, I will see that I don't have any containers running anymore. And that is simply because my container finished the command it had to run. So what I could do now is do Docker run -t -i, which will tell me that I will run interactively. Interactively meaning it does something, I do it from my end as well, and so on and so forth, Ubuntu. And the Ubuntu is the name of the image I want to run. So again, I just said run, and it created on the fly a new container which did not exist beforehand. So if I just open up a new PowerShell, and the reason for why I'm opening up new PowerShell is because this one is blocked into the container which is running right now, and do Docker PS, I will see that particular image and container I just created, right? And if I say here, I could do, for example, pwd. What does pwd do in Linux? It shows me the current directory. I could do things like show me all the list of folders. There is something very specific to Windows guys like me. I could also do ls, which is more specific to the Linux world. I could say change the directory to be, I don't know, just tell me something, home. Let's go to home. I'm changing the root folder to be the current directory to be home. If I do pwd, you can see that I am in home right now. I could do ifconfig, and I could see whatever. I could see, I don't have the command running right now on this particular image. I could basically do commands in the container, right? The moment I say exit, was there a question? As long as there are the libraries there, I can run anything. If I have the libraries for Minecraft, I can run Minecraft, right? That's it. Easy as that, easy as pie. So if I just exit and open up the other thing, I'll see that my container no longer runs, because that was the life cycle of what I wanted from my container. The container, the Docker file specified this is the command. I, within the parameters, said -t -i, this is what I want to do, and there you go, the command finished, so the process was killed. Now, there's another neat thing I want to do here, and that is, let me clear the screen. I will say docker run, and -d means demonized, so this is running background, okay? Demonized Ubuntu, the same image from the same Docker file, and I will say within Ubuntu, run this particular command. So bean s, and I will specify a particular command which will say, while true, don't worry, I have this on my cheat sheet. I don't know how to write Linux code by myself. Hello, awesome people from Poland. I will just close this guy, semicolon, sleep1, which will say that iterate through this guy and also wait for a second, done, and we're done, and there we go, boom. And this is the ID of the container, right? This is -d, this runs in the background, this is demonized. Here's the code I'm running. There you have it. Hopefully it's running good. So if I do docker ps again, I see that my container is still running. And for the past 14 seconds, it was running continuously, because it runs in the background. Now what I could do is do docker logs and show all the logs from the container named backstabbing hawking. Fun fact, so it turns out the names of the containers, unless specified, will be randomly created. But rather than doing it like randomly, like Microsoft would, 1, A, 2, B, C, 3, whatever, they take a random adjective from a dictionary of adjectives and the random name of a scientist from a dictionary of scientists who lived throughout time. They will concatenate the two, and funny things will come out, like backstabbing hawking. So if I just do docker logs, backstabbing hawking, blah, 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 there I go. All the logs which were outputted by the command which ran within the container, which I just created, within a few seconds, it could have been faster had I known Linux better, just like that. And if I want to stop that thing, I will just say docker stop, backstabbing hawking, docker stop. Takes a while, and poof, come on, stop it. Backstabbing hawking does not want to be stopped. Docker ps, the container no longer is there, okay? Easy as that, easy as pie. Now, question. Let's see what would happen if I would take, there is a particular image which is used especially for tutorials and trainings and stuff like that, which is called training. So I'm going to do -d. Training is the name of the repository. Web app is the name of the container. And I will just specify, like in the Python example I had on my slides, run the Python command, and here's the Python application I want you to run, okay? So what's going to happen right now is that it will run a container, but I will also specify -p. -p basically says, I want you to open up a port on the container. By default, it's going to be 5,000. And I want you to create a listener on the host machine of your Docker environment, which will listen for incoming connections and send those connections, like the dormant thing, over to the container, right? So I could just do that, hit enter. There we go. The container is created. Let's just check that. There it is. Grave Raman. It runs. Nice. And what I'm going to do next is I'll just specify, look at this thing over here. So the public port from my host is going to be 30,768, whatever. And the port on the container side is going to be 5,000 instead. So what I'm going to do here is I'll just go to localhost 32,768, was it? Yeah. Enter hello world. And there I have my web application running within a container, just like that, right? I can just say docker stop grave Ramon and hit enter, and my application will no longer run. Just like that, super easy. No configuration required, nothing like that. Now you could say, okay, but these Python apps, they're small, they're like, don't care. Docker PS, it's no longer there. Let's do Nginx. Nginx, another thing from the Linux world. This is probably the thing I'm going to finish my Linux demo with, because afterwards I'm going to do Windows, which is way cooler. So Docker run, where's the Nginx example? I had the name right somewhere around here. Where are you? Where are you? Cheat sheet. Show me Nginx. Nginx. There it goes. So I'm just copy pasting because I'm so low on time. So basically, rather than specifying capital P, which stands for whatever random port 5,000 is the default on the container side, I'll say small caps P 8080, which means on the 80 public port on the host side has to be mapped to the 80 port on the container side. I'll just run this guy. The name of the container will be web server rather than whatever default you're going to create. And now let me just quickly go to localhost, and there you go. I have Nginx running on my computer. I didn't have to install anything on my Windows environment to run Nginx. How cool is that? Come on, that's like the best thing in my opinion ever. And if I just stop it, docker stop, just to prove it to you guys, I no longer have a random name. It's web server. I will just say docker stop web server. There we go. Refresh the thing, and boom, it will eventually time out with for there's nothing like that. Good? Awesome. So, impressed? Come on, this is cool. Woo! That's good. That's good. Now, everything I ran here, because of the internet connection, wasn't running so good because I magically got a very fairly super duper internet connection from Romania. It was because I'm actually running something called Docker for Windows. Now, Docker for Windows basically helps me create, come on, dude, open, about Docker. There's this nice whale. It's the latest version. I'm running the coolest things ever. Now, this thing, what it's going to do is that it will create within Hyper-V a VM which will by default be called Moby Linux VM, and it's obviously running. So if I just gonna stop this guy, exit Docker, none of my commands will longer work. Docker is still running. Come on, please be shutting down. It's no longer running. Good, there we go. Now what I'm gonna do next, because I only have that much memory on my laptop, I'll open up, so that's the reason for why I had to close down Docker for Windows. I'll open up a VM which runs Windows Server 2016. And this will have full container support. Challenge accepted. Yeah. Good password found. The way you install Docker on Windows Server 2016 is by doing something like this. So this is basically a PowerShell bunch of commandlets calling, which say install package provider NuGet, because yeah, there is that. Install the particular module called Docker Microsoft Provider, and then install the package called Docker with a bunch of different parameters, and then restart the computer, because, you know, Windows. Everything has to be restarted after an update. So, I did not just say that for the recording. Oh. Let me open up PowerShell. I'll do it with admin rights just to make sure that everything will run on the very little time I have left. And I will do something like Docker pull, and this will download stuff from the image, from the registry hub of Docker. And I will say, Microsoft, be ready, Windows Server Core. And this is basically the image I will run. Let me make everything larger, because you're probably gonna get your eyes hurt otherwise. this will basically download all the libraries and binaries for running containers with Windows underneath rather than Linux. And that's it. Right? So the host is Windows Server 2016, whatever you see here, and the containers are going to run on this thing over here. But pool only downloads the images. So I can do docker run Microsoft. Sample.net is one of the names of the containers they have in the Microsoft repo. And this will just list out something which was created by using .NET Core, which is this guy. This is always fun. This is always fun. So what I could also do, and this is actually quite impressive, but because I almost have no time left, I'll just cheat here and copy things. I'll do this. So basically, what does this look like for you guys, especially those for you who have attended my SQL session yesterday? Docker run -p port 1433 TDS default endpoint -v, whatever, what -v is, blah, 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 C temp, don't care about that. Environment, attached databases, named max test, and the files come from one MDF and the other LDF, and the name of the container is. So basically, just by hitting enter, okay, not this one, because this was the example one, this one is way better. This one also specifies an SA password. Just by hitting enter, a few seconds later, I have a full environment of SQL Server Express 2014 running with 2 databases attached to it, and there you go. No longer need SQL Server? Docker stop. No longer want to have the containers ever referenced? Docker remove. And there you go. That's it. No restarts. Woo! That's nice. Come on. Awesome. That's what I was expecting. Now, I only have like 2 minutes left, so I'm going to skip some of the things I wanted to do originally. And that is, let me show you this thing over here. So if I just paste, copy, paste, what I'm going to do here is basically start a Docker file, but not actually save the file. And I will say from the Windows Server core image, and this can also be the nano server if you want to have a very lightweight version of your Windows kernel, do command echo hello world, and then build that image, like whatever the string is, and name it Mang Windows test image, and let's just rename this to netdd, because I already have the repo running. So if I do this, it takes my string, which is a Docker file, saves it in an image, which is locally. I could also say docker push, and it will take it from the local store, put it up on the registry hub, and I could also say docker run Mang, what was the name again? Mang Windows test image netdd. Windows test image netdd. And boom, I have my own container created within seconds. So how would you do it with your own applications? I have like a bunch of different kind of paper. I know the solution for this. So I didn't have time for the demo. I'm not going to waste time with you and waste your time actually on this. I'll post everything I just have right here on GitHub. So if you want to do them by yourselves, you will happily be able to do it. My GitHub account name is amang2205. My Twitter account is mang whatever. I will show it in a second. So we can just take it offline. But the idea is that if you have the application lifecycle management in your front right now, building, testing, and shipping is only done in a matter of commands and seconds, right? You no longer have to worry like, what the heck did the developer want from a sysadmin's perspective? That he also wanted me to install whatever patch KB7614, la 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 la, in order to run the application. Everything is defined inside a single file, and everything is provisioned within seconds rather than minutes, tens of minutes, or even hours. Good. With that being said, I'm right on the hour mark. I have a bunch of useful resources. Cameras out, blah, 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 blah. These are the things you don't usually find on Bing, not even Google. And yeah, pictures taken, record, saved, still image moved, and there we go. Sorry for the rest of the guys. Boom, Q&A, no time for that. fun thing over here. No time for that either. Thank you. Woo! Awesome crowd.